Hi, lesson on elements, mixtures and compounds. I'm just going to do a few demonstrations to reinforce the ideas that I've been through on my videos. So the first one I want to set up, which takes a bit of cooking, is it's called the Hoffmann Voltammeter. But you don't need to know what it's called. What you need to know is that this apparatus here, this one, is filled with water. So water, H2O. Water is made of hydrogen element, oxygen element joined together as hydrogen oxide. And what electricity will do, DC electricity, if we pass it through water, it will split it up into the individual elements. So it'll split it up hopefully into hydrogen and oxygen. We need to get that going. We need to pass electricity through it. Now, this isn't pure water because the conduction of electricity is really bad with pure water. This is water with a few drops of sulfuric acid in to help the electricity go through it. But as you can see, we've started, and the bubbles are such that on one side I'm getting hydrogen, on the other side I'm getting oxygen, and later when I've got enough I'll collect them in these test tubes and I'll prove to you that one is oxygen, one is hydrogen. And if you look, on this side we're collecting twice as much gas as on this side. So this will be the hydrogen and this will be the oxygen, and that's why the ratio of hydrogen to oxygen within water is 2:1, and hopefully we'll see that later, but that will take probably about 15-20 minutes to cook and give me enough hydrogen to test. So we'll just put that to one side while I do a more standard demonstration of elements, mixtures and compounds. So I'll come back to that. Right, the most famous of the elements, mixtures, compounds, practicals and demonstration is one that involves sulfur, yellow powder as an element, iron, tiny pieces called iron filings or iron filings. Again, that's pure iron in there, like iron powder. That's pure sulfur in there, sulfur powder. Both of these are elements. You find them on the periodic table. Sulfur, the symbol is S. Iron, the symbol is capital F, lowercase e, Fe. And those two elements, we can try and react together. And we can try and react them together by mixing them. And here I've got a third test tube where they are mixed together. Well, let me get another Bunsen burner. So hopefully you can see with this Bunsen burner what I'm going to do a little bit more easily. That's the middle of the frame, like that. So I've got this mixture here, mixture of iron and sulfur powders. I've kind of tried to make a sturdy mixture like that to heat up, and when I do so I need a test tube holder. 1 minute, let me get a test tube holder. And in order to encourage the iron to join with the sulfur and make a new compound called iron 2 sulfide, in order to encourage the two to join together, all I need to do is, using a Bunsen burner, I need to heat up the mixture. So I've got a Bunsen burner here, roaring flame, heat it, pointing it away from people, and you should see that as it gets hotter, then the colour inside first changes. The colour changes as the sulfur starts to melt. So sulfur's melting, But then, when it gets hot enough, you can see there, it starts to glow. And that's when the two elements are joining together. That glow is famous for knowing that the two elements are indeed joining together. And you can see it glowing away there, glowing away. And we might have some extra sulfur left over, or we might have some extra iron left over. But definitely we will have some compound that we've made called iron 2 sulfide. Now, how do I show you the compound? Well, I have my own way, which is not standard, about showing you the compound. And what I do is I take a beaker of cold water and get the test tube and get the glass really hot and plunge it in the cold water. The glass should crack, leaving behind the new compound that we've made. So I'm just going to do that. Get the glass nice and hot and plunge it in. Now let's have a look at that. If I fish out what we've made, we have made that. Now, I don't know if you can see that very well, but that is a lump of iron 2 sulfide. And that compound, iron 2 sulfide, is not in any way like the element sulfur that we made it from, and it's not in any way like the iron element that we made it from. Compounds that we make are nothing like the individual elements that make them up. And that is not magnetic. Well, iron is magnetic. That is not got a low melting temperature, which is something that sulfur's got. Obviously sulfur's yellow, that's not yellow. There's so many differences. I want you to think, whenever we make a compound, it's a totally different material. You have to go and research it and find out its own properties. You can't guess the properties knowing what elements made it up. That's really quite a very important point, that the properties of the compounds are nothing like the elements that make them up. I don't know if you can see this. This is cooking nicely, probably about halfway there. We'll let it cook a bit more while I do something else, but I need a power pack. So I think I might stop the video there and come back to it in, say, 5 minutes. I'll come back to it and play it again when it's cooked a bit more. Okay, so I've got another power pack, and I've got this apparatus here, beaker with some electrodes, and in there I'm going to put some zinc chloride solution. So to make zinc chloride solution, you get some water and you dissolve a chemical called zinc chloride, which is a white solid. Dissolve the zinc chloride in water and put it into a bottle and label it zinc chloride solution, which is this. Zinc chloride solution. I put some of that in here, and I'm going to get the power pack and I'm going to connect one electrode to the positive, one electrode to the negative, and turn on the electricity and see if I can break this compound down, the zinc chloride. I'm going to see if I can get from zinc chloride solution, I can separate the zinc and the chlorine from it by passing electricity through it. Very similar to the Hoffmann Voltammeter that's cooking on this side. So I'm going to let that run for a bit, and hopefully you'll see that on this side Let me just disconnect it. Hopefully you can see on this side here we've got solid zinc. So zinc is being produced on this side, and the bubbles that were coming off on this side, the bubbles are chlorine gas. I don't want to run it for too long because I don't want to smell the chlorine. But if I do it again, can you see the bubbles? The bubbles that are coming off the electrolysis there is only on one electrode. So on this side we're having chlorine, on this side we're having zinc, and they are the elements that zinc chloride is made up from. And I've managed to separate the compound, zinc chloride, separate it into the elements that make it up. Now, coming back to the Hoffmann Voltammeter here, if I adjust the camera so you can see what I'm going to do, this is towards the top of that Hoffmann Voltammeter now. Right, so I'm going to collect here. Look, I think I've got enough hydrogen, maybe not enough oxygen to relight a glowing splint, but we can try. Maybe there's enough, we'll see. So look, I started with this one. This is water, pass electricity through it. I get bubbles on both sides. Hopefully you can see the bubbles happening on the video. And as the gases build up here, I've got a build-up of a gas. Here I've got a build-up of gas. Look at the volumes. The volume there is only that much. The volume there is that much. So the volume here is double the volume here, and therefore this will be the hydrogen, and this will be the oxygen. The hydrogen should be connected to the negative side of the battery, and the oxygen is collected at the positive side of the power pack. You can't see the power pack because it's down there. It's a very long apparatus, so sorry about that, but let me prove to you that this here is indeed hydrogen gas. Now, where do you learn that this is hydrogen gas? Well, maybe in general science you've done before. You should know that to prove hydrogen gas, you collect the gas, you light it, and you listen for a squeaky pop. So squeaky pop test. Light it, squeaky pop, proves it's hydrogen. So look, here, I'm going to get the test tube, open this tap, we'll let the gas out. There, I've got a test tube, I've got a splint. If I get the splint lit, like that, this test tube, it has got hydrogen in it. If I take my thumb away and light it, there, thumb away, squeaky pop. So that was hydrogen gas. So on the other side, how can I prove that's oxygen gas? Well, that's going to be a bit harder because I'm going to use this test tube, and I won't get a test tube full of oxygen when I could be confident that the splint will relight. So going back to general science, what's the proof that we've got oxygen gas? Well, the proof is you get a splint, you light it, that's a lit splint, and you blow it out. That is a glowing splint. When a glowing splint relights inside the gas, then at GCSE that gas must be oxygen gas. So that's what I want to try and do. So I'm going to collect whatever oxygen we've made by opening this tap. There. I'm going to get my splint. Actually, let me get a longer splint because I'm going to plunge it into the test tube. There's a longer splint. Now, if I put it in and it relights, and I pull it out and it's lit, that's proof enough for me. Watch. I'm going to blow it out. It's out. There. It relit. It relit the glowing splint. Maybe there's enough oxygen to do it again. I'll just try once more. There, it relit the glowing splint. So when a glowing splint relights, then we know the gas is oxygen. And coming back to the Hoffmann Voltammeter experiment here, you are getting hydrogen, you are getting oxygen. We have got it from the water we started with. We have broken up the compound water into hydrogen and oxygen, ratio 2:1, and that should reinforce your ideas of what a compound is. And here we've broken a compound down. Now, the zinc chloride, again, we broke the compound zinc chloride down into zinc and chlorine. And the sulfur and iron, here we joined together the sulfur and the iron and made the compound iron 2 sulfide. So 3 demonstrations. There's just one more thing I'd like to do just as an interesting thing for you. Let me get the camera pointing down again. Now this here is what we call the bomb. I'm not sure that's its official name. I think it looks like a bomb. We just call it the bomb in school. But it's similar to the Hoffmann Voltammeter in the sense that in there we've got water. And the water's got a few drops of acid in. And if I connect up the electricity to the positive and the negative that we've got and turn the electricity on, then you should see we get bubbling. Bubbles here, bubbles here. This is the negative side, that'll be hydrogen bubbling. On this side, look, that's the oxygen bubbling. The electrodes are made of platinum, so that's a very expensive metal. But we need platinum to stop the oxygen reacting with it. Platinum is very unreactive. So as these 2 gases are given off, then look, the 2 gases are made in the bomb. They have to exit through here. There's no other exit. They exit through this tube, and on the end of that I've got a glass wand, and what I can do is get some fairy washing up liquid there, fairy washing up liquid, and perhaps bubble the bubbles that we get. I hope you can see the bubbles. We're getting the bubbles of hydrogen and oxygen are collecting above the fairy washing up liquid. So I've got a mixture in the bubbles, and what I can do is I can ignite that mixture with a Bunsen burner, light my splint, watch, listen, bang. That is hydrogen and oxygen joining together, making water. So the bubbles are a way of keeping hydrogen and oxygen above the fairy washing up liquid, and then lighting it joins together the hydrogen and oxygen, and hydrogen and oxygen joining together is always an explosive reaction. I'll do it once more. See, look, hydrogen and oxygen joining them together. I hope you heard that. So